Okay, we're going to take a look at some problems in quiz 3 of our polynomial unit. This first question says, we've got the two graphs shown, um, g of x in red, and get zoomed in here a little better, and looks like kind of a purplish, another darker color for f of x. It says indicate all the points that represent solutions of f of x equal to g of x by placing points in those locations. So this is one of those interactive graph problems. So when you set two functions or two equations equal to each other, graphically what you're doing is you're looking for where those functions share a point, share an output value. So here I see a point of equality or an intersection point, and I see another one right here. And we just do a quick scan, make sure we're not missing anything. We've got kind of a exponential decay with f of x, and then a rational function here, which is why we have two pieces to it. Um, those are the only intersection points I see on this graph, so let's check our answer. All right, let's go to the next question. Okay, we looked at some like this in class, so we've got two functions. An exponential here for f of x, which is in kind of a teal color, and then g of x, an absolute value function that's been transformed. So kind of phase one of this is to take a look at the graph and realize, hey, we don't have g of x's graph on here yet. We just have f of x. So we're going to use these points and move them around with our mouse or our touchpad to make it look like what g of x should be like. Now, I'm banking on the fact that you've seen the difference in linear functions, absolute value functions, quadratic functions, exponential functions, and logarithmic functions in the past. These are different families of graphs. So because we have absolute value bars in this one, it's not just a linear function, it's an absolute value function. As soon as you select that family of graphs, it changes the parent function. So now we can use this to illustrate what we've got here. So g of x has a x minus 3 on that inner layer. So that tells me I'm going to take this vertex point and move it over to 3. This plus 4 on the outside is a shift up 4. So I'm going to take that up to 4. So I've got the vertex in the right spot. Now with this negative out in front leading the 2, I need to flip the thing down. Now normally, normally an absolute value function will go to the right and then up or down 1. In this case, it's down because, again, we have the negative leading the whole function. But because it's a 2, a negative 2, it's going to go right 1, down 2. So that shows a vertical stretch. Okay, so phase one's done. We've got ourselves the graph. And by the way, you can come about this graph by using your graphing calculator or a website application like Desmos and just punch in this function for g of x and get the same graph. You just come here and move the points around until you get it to hit the same values. Okay, so down at the bottom it says let x sub 1 and x sub 2 be the solutions of what amounts to f of x equal to g of x. And they stipulate here, when you find x1 and x2, label x1 such that it's the larger of the two. So it's got to be bigger than or greater than x sub 2. So as you go into this, you're looking for, I'm using my mouse, I don't know if the video is picking this up, but I'm hovering over the intersection points of f of x and g of x here. So it looks like our first one's right at 2, 2, but then the other intersection point looks to be at like 4.3 and 1.3. So since the two x values are 2 and 4.3, 4.3 will be our x1. It's the larger of the two x values. So I'm going to estimate 4.3 based on the graph and its intersection points. Hey, that's wonderful. Let's keep moving. Okay, let's zoom out just a little bit there. Okay, so this problem says you've got a natural log t plus 4 plus t, and then 2 to the t minus 4 for the other function h of t. These are already graphed, okay? Now down below, in fact, they actually have another function on there called y equals 1. And they've got all these intersection points labeled. So which of the following appear to be solutions of natural log of t plus 4 plus t equals 1? So remember, natural log of t plus 4 plus t is our f of t function. So that is the blue curve here. And now setting that function, setting the value of that function equal to 1 is setting it equal to this height of 1, okay? So it says, which of the following appear to be solutions of that? Well, the solution of two functions being set equal to each other is the x value at that intersection point. Here we're dealing with t's instead of x's, so t sub 2 would be our solution. So I'm going to select t sub 2, and because it doesn't intersect, referring to f of x or f of t here, the blue one, and y equals 1, the orange one, because those never intersect ever again, that's the only one I'm going to select. Let's see how we did. Whew, we did it. All right, next question. So we've got a logarithm base 2 of x minus 1. Again, things I'm thankful I don't have to graph right off the bat here. The only thing we have to figure out is this quadratic. 3 times is g of x, 3 times x minus 5, quantity squared minus 8. So this is just like the one a couple questions ago where we need to pick the family of graphs that we want to go with. And because this has a power of 2 on the variable expression, we're going to go with a quadratic. Again, you're welcome to pause the video and make sure you can graph this either with a graphing calculator or by doing the transformations like I'll talk through here. So I'm going to start with the shift, right 5, and then down 8 with the vertex. So this point right at the origin is going to go right 5. Well, see how that's at 5? I got to move that over. There we go. Right 5, and then down to negative 8. Okay. Now, the only other transformation here is that we've got a vertical stretch. A multiplier on the outside layer is going to be a vertical stretch as long as that value is larger than 1. So this dot, for a function, for a quadratic that doesn't have a vertical stretch, you would go from the vertex right 1, up 1. But with a vertical stretch of 3, you're going to go right 1, up 3. I love how this interactive graph just changes that instantly. So I'm going to take some time here. Maybe I'll zoom in just a little bit here so we can see real well. So we are looking for, let me scroll down. What are we actually looking for? So x1, x sub 2 are solutions of, and there they go again, setting the two functions equal to each other. And we're going to earmark x1 as the larger of the two x values. That's what we're looking for. Okay, so look at the intersection points between the parabola and this other function, this logarithmic curve. And the larger x value is going to be on this intersection point to the right. That's going to have an x value of, it appears to be 6.1, maybe 6.2, somewhere in there, and a y value of negative 3.9. They're only asking us for the x values. So I'm going to use that x value. What did I say? 6.1. All right, let's give it a try. 6.1. And I'll check that one. Again, if this is slowing you down to in terms of, hey, I know how you look for intersection points, but how in the world are you getting that parabola so fast? Please don't hesitate to use an app like Desmos. This is what the icon looks like, and the interface looks like on an iPad, probably very similar on an iPhone. and you can type in things like we just did here, 3 parenthesis, there's an x over here. What was it, -5? I think it was -5. And you could square the quantity and then subtract 8. Okay? So you can get a good idea. You can start to touch the graph here and trace and see, okay, I've got a point down here at the vertex. And then from there, if I go, oh, let me put a point there. Well, you could trace with your finger and you can find other points, like x-intercepts. You can verify that way. That's a helpful way to do this, but then you're just going to look at the graph and estimate the x values, okay? And since they give you the other formula here, the log base 2, if you were so inclined, you could graph that on the other app, on the grapher or on your calculator, and do the whole thing on the calculator. Okay, all right, here's the last one, I think. And 3 times natural log of x plus 4 for f of x, and g of x is negative x cubed minus 2x plus 1. All right, the graphs of f of x and g of x are shown. Okay, great. The point A comma B is on the graph of the functions, and it's right where they intersect. You notice that? So g of x in teal, and then f of x is like a darker purple. A comma B is right where they intersect. So let's see what the question's asking us. It says x equals a is a solution to which of the following equations? Okay, so now we got to remember f of x is the natural log, g of x is that cubic. Remember what solutions are, okay? Solutions are the x values where things share the y value. Okay, so if they're saying x equals a is a solution to which of the following, hey, that's right. Okay, so if I put in a on either of these functions, I'm going to get a height of b. All right. So I don't agree with option A because it's saying if I were to put a in for x, I would compute this. I wouldn't get a. They're saying I would get, or I wouldn't get b. They're saying I would get a. So I don't like option A here. But I do like option B. That's where the two functions are equal. So if you put a in for either the f of x or the g of x, which is your left and right side of the equal sign here, you would get the y value on both sides that's b. All right, so I'm going to go with B. None of the above doesn't make sense if I'm going to pick B. So A was out. Let's see if B did it. Oh, good. We are done. So that's a run through of 5 problems. There you go. And I'm going to leave it right there so the video doesn't get too long. I hope that helped.